Okay, so proving trig identity. So identities means represent all the things that you remember, right? You were tested on. Those are identity, like sum and difference, square identities. So identity means they are always true. The left side equals the right side, okay? So for example, in question 38A, right, you see on the left side, you have a whole bunch of stuff, right? You have, give me 1 second. Okay, the app froze. Okay. Oh, here we go. Okay. Yeah. So the left side, you have sine, you have cosine, you have cotangent, right? And then on the right side, you have cosecant. You want to show that they are the same, right? The left side equal to the right side. So that's called an identity. So we can prove that by using the identity you memorized. Okay, so of course, you can have the identity sheet beside you, right? But if you haven't memorized, it will be more handy, right? You can see, oh, right away, I can do what, right? Instead of looking a list, then you don't know which one to pick, okay? So of course, there are some general rules to follow, okay, of where to start. So fill that in first. So on the top, you see 4 blanks, right? Number 1, change to something, right? Number 2, number 3, number 4. It's not in particularly order, okay? So you don't have to always go number 1 and then 2 and then 3, right? But most of the time, you do number 1 first, okay? So the number 1 is called change to sine or cosine. Okay, so if you see something that's not sine or cosine, you change to that if possible. Okay, because you have more identity that has sine cosine. Okay, and then once you change to that, number 2, you can start to use identities. Okay, so identity refers to the double angle, the square identities, if they're square, right? Okay, sum and difference, we don't use that here because sum and difference, you need to have 2 different angles, right? A and B. But in these exercise, they only have 1 angle, theta. Okay, so sum and difference, we don't need it. Okay, we can write that down. Other than sum and difference. Okay, you can use everything except sum and difference. Okay, number 3 and 4, we'll look at it later, okay, when we see other examples. Okay, any questions so far? We're gonna try an example, okay, so you see how it goes. So you have left-hand side and right-hand side. Usually we start with more complicated side. Okay, so that's a general rule, because if you have more things to work with, you have more identity to apply, right? You can try to simplify it. So for this example, we're gonna start with the left side, right? So we can write LHS. Okay, LHS means left-hand side. So I know you're starting with left-hand side. So you have sine theta plus cosine theta cotangent theta. Okay, I just copied the left-hand side again, okay? So we'll look at that left side. Which one is not sine or cosine? Evan?
The cotangent.
Yeah, okay. So do you have any identity that has to do with cotangent? Evan? Any cotangent identity that comes up to your mind?
Reciprocal?
Okay, so cotangent becomes what? Yes, still
It becomes a 1 over tangent theta.
1 over tangent theta. Yeah. So is there another one that has to do with sine or cosine for cotangent? Let me ask someone else. Okay, Angela, what do you think? Is there an identity that can change cotangent to either sine or cosine? Angela?
Wait, sorry, what was the question?
We have cotangent here, right?
Yeah.
Yeah, okay. Can you tell me if there is an identity that can make cotangent become either sine or cosine?
Quotient?
Okay, which one?
Cosine theta over sine theta equals cotangent theta.
Very good. Okay. So we are going to use that one. Okay, instead of using 1 over tangent, because if we can change to sine or cosine, then we pick that one. Okay, over the other one. So we are going to write everything else stay the same. Okay, except the cotangent part will now become cosine over sine. Okay, and then we're going to simplify it. So sine theta still stay there. Okay, so cosine theta times cosine over sine. Cosine is like cosine over 1, right? Cosine theta. So multiplying fraction. So the top will become cosine squared, because cosine times cosine over sine. All right. Now, because you have two things together, right? We want to, if you look at the right-hand side, our goal is to make it into one item, right? We need to add them together. So that leads us to our third direction, okay? Is to combine fractions. Okay, you can fill that in, combine fraction. So either you add them up or subtract them, okay? So you combine them. So how do we add the two fraction, like the two terms here on the left side, on the left hand side, okay? Sine theta plus cosine squared theta over sine. Okay, Sophie, how do we add them up?
Sorry, can you hear me now?
Yeah, I can hear you now.
Okay, could you repeat the question? My mic wasn't working properly.
Okay, so did you hear I said we can combine the fractions?
Yeah.
Okay, so my question is, how do I add these two things together now? The sine and the cosine square over sine. How do we add them up?
Do you
Combine.
make sine theta into a fraction as well?
Yeah, how do we do that?
Sine theta over 1, and then you have to make the denominators the same, so you multiply it by sine theta over sine theta.
Okay, very good. Okay, so we're gonna write it out slowly. Sine theta, well, I could just write over 1 first, okay? Save a step. So during proof, you want to show as many steps as possible. So then the reader understand that you are not skipping, right? You cannot say, okay, my next step is cosecant theta. Finished, right? That will be jumping too much, right? So we don't know if whether you understand how to get there or not. You want to show as much as possible, right? As more detail as possible. So we multiply the top and bottom by sine theta, so we can have common denominator. Okay, our common denominator is the sine, right? So sine and 1. So we need to make them both the same so we can combine. Any questions so far? Okay, so now they are all the same denominator. We can write it together. So it still doesn't look like the right-hand side, right? Do we have an identity that we could apply it over here? Does anyone see an identity we could use? Think about what you did in the quiz. Is there anything that shows up? Anybody? Yeah, Daniel, what do you see?
Like sine squared theta plus cosine squared theta is 1.
Yes, very good. Okay, this is part of the square identity, right? Sine squared plus cosine squared equals to 1. You've written it, I think by now at least 3 times, right? So that becomes 1. The denominator still stay the same. And then 1 over sine, okay? What does 1 over sine equals to? Lily?
1 over sine is cosecant.
Yes, very good. Okay, so and then you see the cosecant is the right hand side. So at the end, you finally reach to the right hand side. So you write equals to RHS. Okay, so that will be done. So you're going to start with one side and slowly change until it becomes to the other side. Okay, so left hand side, for this one, we pick the left hand side because left hand side you have more things to work with, right? And then at the end, it becomes the right hand side. Then you know the identity is proved. Okay, it's true, right? Left side equals to the right side. That's our goal. Okay. So let's try another one, right? Can you raise your hand if you finish everything in question A? Okay, Jenny, do you have any questions for question A? Oh, good.
Nope, I'm good.
All right. Okay, so let me see. Okay. Yeah, okay, so let's look at B now. Okay, so where should we start? Jocelyn, do we start with the right-hand side or left-hand side for this one, question B?
The left.
Okay, yeah, left side has more stuff, right? So we start with the left-hand side. Okay, this time I won't copy it again, okay? We can just start to do the change, okay? So left-hand side, we have cosecant over tangent plus cotangent. And we want to change them into either just sine or cosine, okay? Now let's just try the first step, okay? When you finish writing the first step, can you raise your hand? And I'll pick one of you to write it out, okay? To tell me what you got. Okay, please raise your hand if you have the first line. Still writing? And falling asleep. No one's got the first line yet? Okay.
Wait, is it CSC theta over tangent theta plus cotangent theta for the left-hand side?
Yeah,
Oh,
yeah, it's the left-hand side, yeah.
Okay.
Left and right. Okay, so we want to show the left-hand side will become the right-hand side, okay? We're just talking about the first line. What are you gonna do, okay, with the left side? How do you change the left side into just sine or cosine, okay? That's what I want to see right now. Please raise your hand if you have the first line, okay? If it takes 5 minutes to do first line, then one question takes you 30 minutes. Come on. Okay, Waylon, what do you have on the left side?
I got 1 over sine theta. Wait, one sec. Yeah, 1 over sine theta times sine square theta over cosine square theta.
1 over sine squared, 1 over sine theta times?
Yeah.
Times what?
Wait. No, wait, one sec. I'm not sure if this is correct. One sec.
Okay. Remember, for proving, okay, you have to show slow baby steps, right? Otherwise, I don't know how that happens, right? So you just do little change by little, okay? Each time do a little bit of change. So everybody can follow easily, right? What's going on.
Jason,
Yes, Eric?
can I rerun the meeting quickly because I think my audio is a bit broken.
Okay, yeah, I'll let you.
Thank you.
So Waylon,
I'm not 100% sure.
okay, you can tell me what you got, okay? We can talk about it.
I got cosine theta over
Hold on.
cosine.
Let me erase it, okay? Hold on. So cosine theta
Theta over cosine square theta plus sine square theta.
sine square theta. That's the left side?
Huh? Yeah.
Okay, can you tell me where's the cosine data come from?
1 sec, let me check. Wait, let me, I'm pretty sure I did something wrong. 1 sec.
Okay, I'll come back to you. Let me get another answer. Okay, see what other people got. Caleb, what's your first line look like?
Oh, I put 1 over sine theta over tan plus theta plus 1 over tan theta
10
theta
plus
plus 1 over tan theta 1 over tan theta.
like this?
Yeah,
Okay, yeah. Thank you.
I'm still trying to work it out.
Okay. All right, Willem, have you figured it out?
Give me 1 second.
Okay. So for Caleb's answer, right, at least I can follow what's going on, right? The numerator cosecant is 1 over sine theta, right? That's a reciprocal, right? The tangent just stay there. Cotangent reciprocal is 1 over tangent, right? So little change by little, right? Then I can follow why it becomes that. Let me see if other people got a different first step. Okay. Angela, do you have anything? Angela?
I did the same thing as Caleb.
Same thing as the second one?
Yeah.
Okay. Okay. How about you, Chris?
Well, my answer is kind of like the one above.
The one on the top?
Yeah, kind of like that.
Okay, what is it? What do you have?
I have cosine theta plus sine theta over cosine theta plus 2 sine theta.
Plus 2 sine theta. Okay, can you tell me how you get the cosine plus sine?
Okay, so I saw, I'm pretty sure this is wrong, but I saw that the cosecant is equals to 1 over sine theta, so I moved it to the bottom. And then cotangent,
Mhm.
oh, so tangent becomes sine over cosine. So then the tangent equals to sine theta over cosine. So then I move the cosine onto the top denominator. And then cotangent is the opposite, so then I put something else on the top.
Oh, okay, okay. Let me try. Okay, so sometimes the mistake is important. Okay, you need to know what kind of thing you can do, what kind of thing you cannot do. Right? You don't do the same thing in the future. So what he was saying is the cosecant part is 1 over sine. So you move it down, right? Sine. Right? And then tangent you say is what, Chris?
I said it's sine theta over cosine.
So you put sine on the top?
I put cosine on the top.
Oh, cosine, okay. So cosine on the top and then sine at the bottom. Like that?
Yes.
Okay, and then?
Cotangent, since it's the reciprocal of tangent, I put sine on the top and cosine on the bottom.
Okay, cosine at the bottom. Okay, then where's the 2 come from?
Oh, wait a second. I thought that because cosecant
Mhm.
is sine and there's another sine. I just made it 2 sine.
Oh, so you add them up.
Yeah.
Yeah, okay. So there's, when you have something like this, okay, what you can do is think about okay. Think about numbers, okay? So for example, if I have 2 over 3 plus 3 over 2. Normally, right, if you want to simplify this expression, okay, Chris, what would you do? If you have 2 fractions at the bottom, do you do the flipping them first or do you add them up first?
You add them up first.
Yeah, you add it because the denominator is like having a big bracket. So you got to figure out the answer for the bottom part. Okay, and then before you can do the flipping. Okay, so same thing with this part. The tangent and cotangent, you cannot do the flipping yet because they are at the bottom, you have to deal with them. Okay.
Okay.
Yeah, so yeah, so don't move them around yet, okay? Because you have too many fractions inside. Okay, so let's go back up, okay? So far, the only answer that's okay is that I can follow, okay, is this one. Okay, even though this one is not just sine or cosine, okay? Does anyone have a different answer that's just in sine and cosine? Anyone else has different ones? Susan, do you have a different one?
Mine is 1 over sine theta over tangent of theta over 1 plus cosine of theta over sine of theta.
Okay, cosine theta over sine, like this?
Yeah.
Okay. Closer, right? Now we have sine, cosine, and tangent. Is there a way I can also make the tangent go away? So then it's just sine, cosine. Is there identity?
Yes, you can do sine of theta over cosine theta.
Yes, okay, then that will be better, okay? If possible, then we always try to turn it into either sine or cosine, okay? So we have less to deal with, okay? So that's the one we're gonna use, okay? So I'm gonna keep Calem's Calem's way, okay, on the side, and then I will show you guys if I pick a different ways, right? If I pick Calem's way, how would it go, right? Would it still work, right? But then the key point is when you are doing proving, you need to make sure people can follow your work without asking you, right? Otherwise, I can say the second step is cosine, then you're done, right? Then that cannot be approved. Okay, so I'm gonna use sine cosine first, okay? And then I'm gonna go over the Calem's choice, okay? Let me just clear the screen for now. So your very first step is important, okay? Cosecant, it turns into 1 over sine. So remember the sine data doesn't go down, okay? And then we have tangent using the quotient identity, sine over cosine. Cotangent is cosine over sine. Okay, that's the left-hand side. And then now the top, we'll keep it the same for now. For the denominator, you have 2 fractions. Okay, when you have more than 1 fraction, right, we try to simplify, combine. So we'll add up the 2 fractions, just like the same way, similar way that we did before, right? On the left-hand side, like over here, we have 2 fractions, we want to add them up. We need to get common denominator. Let's add them together, okay? So I'll let you guys add them up, okay? The common denominator for this one, okay, what is the common denominator for those two fractions? Eric? What's the common denominator? Eric, are you back? Are you here? Eric? Or Daniel, what's the common denominator for those two fractions?
Cosine theta and sine theta.
Yeah, okay, cosine times sine. Okay, think about how you would add the two fractions like this, right? 2/3 plus 3/2, right? So our common denominator should be 6, right? 3 times 2. So same idea. Okay, it's just in words now, okay? But basically you're doing the same thing. So please figure out the top part, okay? Raise your hand once you got the top. So you can see I'm not flipping anything at the bottom to the top yet, okay? We're just combining. Numerator stays in the numerator, right? I don't move them. Denominator stay in the denominator. Okay, please raise your hand after you got this part. Okay, Nick, what do you have for the numerator in the bottom?
2 sine theta plus 2 cosine theta.
2 sine theta plus 2 cosine theta.
Yes.
Okay. Anyone else has something different?
I wrote 2 sine theta cosine theta.
2 sine theta, and then
Cosine theta.
cosine theta, like this.
Yeah.
Okay, for the denominator, right?
Yeah.
Okay. Anyone else? Sophie, what about you?
I got the same as the first one.
Okay. Caleb?
I got the first one.
Okay. Anyone else? Does everyone got the same thing? How about you, Daniel?
Wait, Jason, which part are you talking about again?
I'm talking about the numerator in the bottom, in the red, these ones. What should go there? I got two different answers for the yellow highlighted, right? What do you have? Do you have the same one?
I got something different.
What do you have?
I have sine squared theta plus cosine squared theta.
Okay. So right now I'm just talking about the red box, okay? And Susan, do you want to say anything?
Yeah, I got the bottom one as well, the squared.
Yeah, the one with the square. Okay, so let's take a look, okay? If you are not sure what to do, then you look at numbers, okay? Remember I gave you an example of 2/3 plus 3/2, right? Common denominator is 6. So for the first fraction, the 3 needs to times it by 2, right? So the numerator also needs to times it by 2. So it'll be 2 times 2. Okay, and then for the second fraction, the denominator is a 2, so it needs to times a 3 to make 6, right? So numerator will be 3 times 3. So same thing with the sine cosine here. Let me erase them, okay? Erase all these. Because with numbers, you know what to do, but with the letters, right? Sometimes you feel confused. You compare this fraction, okay? I highlighted here, right? Yellow highlighted, okay? Compare that. Let me try again. Cosine theta, compare with the denominator, common denominator, cosine sine. It's missing the sign, right? So numerator needs to times the sign again. So your correct writing should be sine squared. Okay, sine times sine is not 2 sine, it's sine squared. All right, now you compare. Okay, so we'll try that again. Okay, so you compare the second denominator with the common denominator. Sine needs to times cosine, right? To make sine cosine. So the numerator needs to times cosine. Okay, so it should be add cosine squared. Okay, try to compare with the example I gave you on the numbers, right? If it's numbers, you need to times it by the missing part, right? Like times 3 times 3. Sorry, not times 3. Why do I write times 3? It should be times 2, right? Times it by 2, times it by 2, right? Times by 3, times it by 3. So your denominator will be the same. Okay, can you raise your hand if you understand how we get the sine squared plus cosine squared? If you still feel confused, you have to let me know, okay? And I'll try to explain in a different way. Any questions? How we get sine squared plus cosine squared? Angela, Daniel, and Evan and Marcus? Okay, so once you get here, right? So first line is to change it to, like, we use the reciprocal, right? And quotient. The next line, we use the combined fraction. Okay, add up the two fractions. All right, and then step 3, what else do you think we can do? Anybody can give an input, okay? We need to discuss this. What can we do now? Any suggestions? Any identities we can use?
You can make sine squared theta plus cosine squared theta into 1, right?
Yes, okay, so that's an identity, right? So you see, I told you it's not in the particularly order, right? So once we combine the fraction, we can go back and look for any identity that we can use, right? So we see sine squared plus cosine squared, it becomes 1, okay? So everything else you copy it again. Okay, so that's the denominator. That's the numerator. Okay, what do we do now? Look at your goal, right? Your goal is try to make it into cosine. How do we make it happen? What should we do now? I cannot just say, okay, next line equal cosine, okay? That's too fast. Okay, you'll get marks off if you are jumping too much because I can't follow. You need to show slowly baby steps, okay? How to get there. What do we do now? Anybody? Does anyone?
Wait,
Yeah, clear.
isn't dividing by a fraction multiplying the reciprocal?
Okay, let's do that then, right? So it will become 1 over sine times what? Clear? Times it by,
Cosine over cosine and sine over 1.
yes, very good. Okay, so the green bracket is a fraction, right? Divided by the red fraction. So when you divide by a fraction, you need to flip the second one. Okay, everyone caught up? So at least now it looks better, right? You don't have a very tall fraction there, right? Rather side by side. What do we do next? What can we do now?
Answer it.
Answer, how? How do you go from there to answer? What do you do?
Like cosine and cosine sine cosine theta sine theta over sine theta, and sine theta could like cancel out each other.
Very good. Okay, so you can show the canceling, okay, when you are writing your work, right? Because this part I can follow, right? I see our numerator can reduce with denominator, okay? So you're left with just cosine theta. And this looks like the right-hand side, then you can write your conclusion equals to RHS. Okay, then you're done. So that's all the proofs should be done, right? Slowly, right? So I can follow what's going on. And remember at the beginning, Caleb did it differently. Okay, but can you raise your hand if you copy everything up to here? Okay. We're gonna go over the other way, okay? So you can see that even though you pick different paths, right? You can still end up the same, okay? We'll see. Okay, please raise your hand if you finish writing down. And then I think Caleb was starting with this one. 1 over sine, the top is the same, but then the bottom, he used the tangent and 1 over tangent. Right, Caleb? This is what you have, right?
Yeah.
Okay. So we're gonna go over this way too, okay? So if you finish writing, please raise your hand. Okay, Jenny, do you have any questions?
Yeah, what does RHS mean again?
Right-hand side.
Oh, okay. Thank you.
Yeah. Okay, so cosine theta is on the right-hand side, right? We simplified the left-hand side, made it equal to the right-hand side. That's our goal, right? Okay, so let's start with a different way, okay? So Caleb said he changed the tangent and cotangent, or tangent stay the same, cotangent into 1 over tangent. So everything using reciprocal, okay? No quotient rule here. So if you got this, if you go this way, the denominator still has two things, right? That you can combine. So we're gonna combine it like what we did here on the previous question, right? Where I put the start, sine plus cosine square over sine, we can add them up by getting the common denominator, okay? I'm gonna let you try that. Add up the two terms in the denominator, okay? The numerator stay the same for now, okay? The green part. So please add up the bottom part. Okay, raise your hand once you got the bottom part, okay? Add the two terms. Tangent, you can think of it as tangent theta over 1. Okay, so add them up. Okay, Waylon, can you tell me what you got in the red box?
Oh, wait, one sec. Wait, never mind. I just saw. Wait, one sec.
Okay. Tangent plus 1 over tangent. How do you add them up? If you're not sure what to do, right? Make up numbers. Think about how do I do 2 plus 1 over 2? Right? How do you get common denominator? How do you add them together? Right? Same thing.
So just 2 tangent theta.
2 tangent theta, like that?
Yeah.
Okay,
Wait, one sec. One sec. Wait. One sec. My bad.
think about how you do 2 plus 1 over 2. Okay, how do you get common denominator? How do you put it together? Do you need any help with them?
Yeah.
Okay, then let's go over the right hand side. Okay, 2 plus 1 over 2. How do you add them?
2.2. 5 over 2.
How do you get 5 over 2? Well, I need steps.
Oh, convert 2 to 4 over 2.
So you turn the 2 into 4 over 2, right?
Yeah.
Plus 1 over 2, correct?
Yeah.
You do the same thing here, okay? You have tangent plus 1 over tangent. So I need to turn the tangent into what?
Fraction.
Yeah. So what over what?
Wait 1 sec.
If you look at the top, okay, 2 is like 2 over 1, right?
Yeah.
How do you make 2 over 1 become 4 over 2?
Multiply both by 2.
Yeah. Top and bottom multiply
Yeah.
by the 2, right? So we're gonna do the same thing here. So for tangent data, how do I turn it into the new fraction?
Will it just be tangent theta over 2 tangent theta?
You need to times it top and bottom by what?
By by tangent theta.
By tangent, top and bottom both times by tangent, because common
Oh.
denominator is tangent, right?
Yeah.
Okay, so what's the numerator then?
Tangent square theta.
Yeah, tangent square theta over
Tangent theta.
tangent theta. Plus, what is it?
1 over tangent theta.
1 over tangent theta, right?
Yeah.
Okay, so now they have the same denominator. We can put it together. So in the red box, what's in the denominator?
Tangent theta.
Yeah, tangent theta. What about numerator?
1 plus tangent square theta.
Yes.
Or,
I'll write it as tangent square plus 1. You are doing exactly the same as the way you would do with numbers, okay? Except just with letters now. Okay, it's
okay.
harder, okay? So if you feel confused, you just make up numbers, okay? Think about what to do. Okay, now what should we do next? Anyone got ahead already? What can we do now? Anybody? Anybody see something we can do from here?
Can you simplify 10 to the power of 2 by 10?
Oh, you mean cross it out?
Yeah.
So tangent square cancels out with the tangent data.
Mm-hmm.
Okay, can we do that? If you think we can you raise your hand? So the rest of you think we can't. Okay, then I need to know why. Okay. Can we or can we not? Can we cancel the tangent square and the tangent, simplify it like that? Okay, Angela, can we?
No,
Why not?
because there's a 1, and then if you want to do it, you have to factor the tangent theta out first.
Okay, yes, okay. So the answer is you can't, okay? Usually, if you are not sure whether we can or cannot, right, make up number examples. So like Angela said, we cannot do that because there's a +1, okay? So let me show you an example. If I have 2 plus 1, okay, there's a +1, right? Over 2. Can I cancel the 2 and the 2 and then just make it into 1 plus 1 now, right? So answer is 2. Would that work? Right, so you can see that the answer doesn't match. If we don't cancel, right, the correct answer should be 3 over 2. But if we cancel, it becomes 2. So of course you cannot have 2 different answers. So what you need to think is the numerator is like having an invisible bracket there. So you need to add them up first. Okay, so no canceling because there's a +1. Okay, very good question here. Okay, because a lot of people make the same mistakes. right? So it's good that we cut this. So if there's an adding, you cannot cancel it out, okay? So back to where we were again. So other than canceling, okay, now we cannot cancel. What can we do instead? Anyone else?
We can turn the tan square theta plus 1 into secant square theta.
Oh, okay. So this is which identity?
Oh, the square?
Yes, very good. Okay. So tangent square plus 1, if you memorize from your quiz, it's secant square theta. Okay. So that's the red part. That's the green part. Still stay there. Okay, and then what? What do we do now? After we use the square identity, Evan, what do you think? If you are here, what are you gonna do next? Evan?
Oh, sorry, say that again.
Yeah, what are you gonna do now? Once we get here.
I'm not quite sure.
Okay, anyone else? Daniel, what do you think?
Wait, what was the question?
What do we do now?
Like you flip it, like
So,
you multiply by the reciprocal.
can you tell me what to write then?
So it's 1 over sine theta,
Mm-hmm.
and then times tangent theta over secant square theta.
Yeah. Okay, thank you. Okay, and don't forget our goal. Our goal is try to get to cosine, right? Our original question. Or is that gonna happen from here? What's next? Anybody can give an input, okay? As long as you have an identity to support it, you can do it. Yeah, Eric?
We change that stuff around so it becomes like 1 over sine theta times sine theta time or over cosine theta times cosine theta squared.
Okay, so you split the tangent and secant square apart.
Yeah, and then we change it all because I think at the end they'll all be on the denominator except for 1 cosine theta.
Okay, let me write it down first. Okay, so I split it. So you can see how slow I'm explaining, right? How slow I write the steps out. So this is how slow you need to write it too. So we can follow your thoughts, right? So Eric did is he split the tangent and the secant square. So then each one, you can use the identity. Tangent becomes sine over cosine. And secant, no, I shouldn't put equal. Secant square is the reciprocal of cosine, right? Cosine square. Secant is, so if you flip it, it becomes cosine. Okay, this part came from secant equal to 1 over cosine. The reciprocal, Okay, so if there's a square, then cosine will have a square. Okay. The reciprocal works both ways, right? So if I flip the secant square, so 1 over secant square, then that means the right hand side will also flip. Okay, so you can, they are reciprocal of each other. So if you flip the secant, it will become cosine. Okay, that's where it came from. So now what do we do? This part should be the best part of the whole steps. What do we do now? Marcus, what should we do now?
Do we combine it all?
Okay, which ones combine?
Cosine.
Yeah, what do we do? How do I write it?
It should be 1 over. Hold on.
They are all multiplying, okay?
So then it should be 1. It should be sine theta. Then plus cosine squared theta
Times cosine squared theta.
over sine theta times cosine theta.
Yeah. And what can we do after that?
Just like divide it. So like when the sine cancel out and then the cosine cancel out and you just get cosine.
Yes, okay. So once you have the multiplying there, very good, Marcus, okay? So you don't need to do one more step by writing the same thing again, okay? If there's not much change. So you can start canceling right away here. Okay, sine and sine, they cancel each other. Cosine and the one of the cosine on the top cancel each other. And then you can write the conclusion, cosine theta, which is the right hand side. Okay, so you can see that we can do the same, get the same result, okay, even though the path is different, right? So with the one question, as long as I can follow your logic, then you will get a full mark. Okay, so remember, do not jump too fast. That's the key part, okay, for proving. You have to show baby steps, okay? So everybody who reads your work can understand what's going on. Okay, we'll take a break. And then after the break, we'll do a few more questions, okay? So I'll see you guys at 11:20. Okay, if you have questions about these two proofs, you can ask me during the break. Oh, and I'm still missing 2 homework, I think. 3 homework from you guys, okay? So if you haven't handed in, please hand it in soon.
Hey, Jason,
Yeah, Jenny,
could you flip to the first page so I could copy down the formulas?
sure.